Hi, my name is John Kingham, and I am the host for today's webinar. Stuart Rochon will be presenting. Stuart is one of my go-to presenters, and he has over 2 decades of experience with Bentley, Nevada. I consider him to be an expert on all things related to 3500 and System 1. We are recording today's session, and in order to make these videos available to you and your colleagues at a later date, we ask that you make sure that you are on mute and refrain from broadcasting your video. We also will be using the Slido app for questions. I always recommend voting on your own question because it'll give it extra priority. And as we are recording, we will wait until the end after we stop the recording to pose and answer the questions in the queue. With that, I'd like to turn it over to Stuart.
Hello. I'd like to welcome everybody to this session. And today we're just going to be going over the System 1 EVO software, a little of the history, some of the information about it, and then actually getting into the software, maneuvering around. I'm going to show you some of the neat features and functions that we have available. So starting off, we're going to take a look at the history. So System 1 started around 1995. The idea was to bring all of our hardware into a single piece of software so that you didn't have to learn multiple pieces of software to be able to do condition monitoring for an entire plant. Before this, we had a separate package for continuous online data. We had another package for scanning data. We didn't have anything for portable, and things were just segmented by hardware platform. So the idea was to build one software package that would bring all of it into one screen. You only had to learn one set of processes for looking at the data. Since that time, we've had about 30 different releases, each added new features, functions, bug fixes, whatnot. So over time, it improved and improved and improved. But as with many things, what you start out with isn't what you need later on in time. Cybersecurity requirements changed, different methodologies, different programming languages. Things have just updated and been done differently. Some of the things that we were told in 1995, like Microsoft was like, DCOM, most secure way to port data. Well, that lasted about 3 years, and DCOM was like the most unsecure way to port data. So Classic used DCOM for a lot of things. EVO does not use DCOM for anything. Also, the methodology for building software has changed. Back in the 90s, everything was just kind of one big pool, and you may write a piece of code and go, oh, I want to use that over in this other section. I'll just link to it. Well, the problem is you may forget that you linked to it, and you change that piece of code to change how something functions in one section, and you accidentally change it somewhere else without being aware of it. This introduces bugs and things like that. So the modern methodology is to build a software backbone and then have separate modules that attach to that backbone and do different features and functions. The benefit is that if I want to, say, update how a waveform is handled in a 3500 rack situation, and not change how it's handled in a 3701, I can change it in the 3500 module and not have it change in the 3701 module. But if I want to change it in the 3701 module to match the 3500, I can just copy and paste it over. Using the appropriate framework and everything makes it very modular, allows you to copy and paste to replicate segments. Takes up a little more data space, but it makes it much less buggy. About 2012 is when we started the complete redesign. It was started out as just for portable data, and then has increased and improved over time. In 2016 was when we released the first of the online capabilities. And now we've built out a very capable turbo machinery diagnostic tool. We are adding new features and functions for recips. We have plans for hydros and other equipment and technologies. So we are continuously improving it. We have 2 releases a year. The version number now relates to what year and what release. So the latest release is 20.1. So that means in 2020, we had the first release of the year. 20.2 will come out probably November, December timeframe. The first release usually comes out the end of the second quarter. The second release comes out near the end of the year. We do offer 3 basic packages. You have the premium, which is your highly critical online continuous data collection. You have the advanced, which is your scanning and basic protection, and fundamental, which is your portable data. You can get an advanced plus, which includes all of the scanning and the portable, or you can get premium plus, which includes premium, advanced, and fundamental. If you just get premium, it does include all of the features of the advanced. Doing it in a modular fashion like this allows you to buy the level of software that you need. So if you're just doing a portable walk-around program, you don't need all the features and functions of the continuous online. So you don't have to pay for those features and functions if you're not using them. These different levels affect how data can be collected. With the fundamental, it's just portable. When you go out and collect data, bring it back and upload it. If you can get out and collect data faster than once every 30 seconds, you are amazing with a portable. So the advanced gives you greater features for data storage, specifically around the scanning systems. So with the advanced, you can store data as fast as every 30 seconds for trends and once per second for alarm data capture. When you get up to premium, you get down to once per second data trend and 100 millisecond alarm and startup shutdown capture. So depending on what you need, you can purchase the appropriate level of data collection for what your needs are. There are other features and functions, but the data collection is probably the biggest of the differences between the different ones. Different hardware have different capabilities of transmitting data. The 3500 and 3701 being 2 of the highest, or I'm sorry, 3500, 3701, and the TDI Secure being the highest resolution data collection units, allowing you to collect the 1 second trend data, 10-minute waveform, forward trend, the high resolution startup and shutdown, and high resolution alarm. The 2300, very similar, just does not have the startup and shutdown capabilities or the alarm data. And then you have the scanning items like the VB Online, Trendmaster, and Ranger Pro. We did mention these startup shutdown data profiles. So 3500, 3701, and Orbit 60 all have these startup shutdown high-speed data collection capabilities. So to start this, you set up a enter and exit trigger. And for shutdown, your exit trigger is your enter and your enter is your exit. So you set up a upper and lower speed that is outside of your normal running speed. So for say a 3600 RPM steam turbine, you might set the lower trigger at 200 RPMs, the upper trigger at 3540, 3540 RPM, so that there's no time that during a normal running you drop down to that speed and trigger a startup shutdown data collection when it's not needed. And anytime System 1 sees a speed in that range, it will send a message to the rack to say, hey, I need you to dump your data buffer and start collecting data based on the delta RPM and delta time that are set up in the software in System 1 EVO. So the delta RPM will take a steam turbine, for instance. You may set that up to collect every 5 RPM. So as you go from that inner trigger of 200 RPMs on forward up to, say, a heat soak speed, 1400, something below your first resonance, it will collect on that delta RPM of every 5 RPMs. And that is for static samples. And every 50 RPM, it would collect a waveform sample. So for every 10 static samples you collect, you get 1 waveform. Then as you hit that heat soak at the 1400 or so speed, it will then collect on delta time. This can be anything down to once per second. Generally, it's every 10 to 30 seconds, depending on the length of the heat soak. And for every 10 delta time static samples, you get a waveform. So if you set it for every 10 seconds for a delta time, every 100 seconds, you'll get a waveform. Then as it reaches close to operating speed, it will see that trigger and it will start a timer. This timer is an amount of time set in the software as to what it takes to get the machine to a settled and operating state. So say a power generation, you ramp up to speed, you get to 3600 RPMs, you let everything stabilize, you synchronize to the grid, then you have a window where things are just kind of settling out, maybe 45 minutes, an hour, or something like that. So this additional time can be added on that, and during that, it will be collecting in the delta time sample rate. So this gives you a great picture of what's happening with the machine as it starts up. You can pick out your resonance frequency for the machine. You can save this as a compensation or overlay for later startups or shutdowns, and be able to do analysis if you had a failed startup or if you have an unexpected shutdown. We also have the alarm data file. This is a continuous rolling buffer in the 3500, 3701, and Orbit 60. And when you hit a alarm set point, it dumps this about 10-minute buffer that is 1 second data and your standard waveform collection, which is in EVO every 10 static samples. That continues until you get to about 20 seconds before the event, at which time it switches to the ultra high resolution and you get 100 millisecond trend data. It's still on 10-second waveforms, so for the 30 seconds around that time frame, you get about 3 waveforms. And then it switches back to the once per second and every 10 seconds for waveforms. This is for every point associated with a key phaser or added to a collection group. So if you have OPC data points coming in from the DCS or from a historian, these will also be collected in sync with the vibration data, thrust, differential expansion. Any of these data points can all be collected in this high resolution format. And this is not just for a hardware alarm. This also includes software alarms. So if you set a software alarm in the System 1 software, the software will send a message to the rack saying, hey, I need this data buffer, and we'll store it appropriately. Speaking of storage, with the move from System 1 Classic to System 1 EVO, we moved from Microsoft SQL Server to now we are using SQL Postgre database. We found that Microsoft SQL Server gets unstable when we get up to about 300 gigs of stored data for this high speed in and out rolling data. And so moving away from that, we moved to Postgre, which is happy with terabytes and petabytes of data. With that change, we were able to change how we store data. In System 1 Classic, it was based on change filters. So once a sample was taken, it would then watch for a percent or value change of X amount before it would write another sample. So you also had a minimum time between samples and a maximum time between samples. So if it didn't change for, say, 6 hours, it would write another data point just to give you another point on the trend. And if it was changing rapidly, it may have a minimum time between samples of, say, 30 seconds. So it would not write another sample for 30 seconds, no matter how much it changed. The problem with this is you really don't have great control over it. If a point goes erratic, damaged cable, damaged sensor, damage to the shaft, just scratches or something like that that you can't do anything about, it can make the variable go very erratic, and then you have maybe 3 days worth of data because it's X number of samples, and then you're just trying to manage how much time you get out of that number of samples. With EVO, we said, forget it. We're just storing everything at 1 second, and then we'll do a filter after that. Because we have that capability to store in the terabyte and petabyte space, we are storing everything at once per second. And then you have a filter. So here it is set up for once per second for 30 days. This is configurable. So if you want 60, 90, a year worth of 1 second data, as long as you got the data storage space for it, you can do it. But in this example, after 30 days, it will do a filter to 20 seconds between samples. And it will take a first in, a minimum, and a maximum value. We found that this gives us the most accurate representation of the overall shape of the trend. And there is a secondary filter here. So after 6 months, it goes to 1 minute data. And after a year, it goes to 5 minutes for 5 years. So with this methodology, we can specifically state, okay, I want to collect data for 5 years. And no matter how erratic a point gets, it will still collect for 5 years. So it makes the data storage management much, much easier. This is just for continuous trend data. The alarm and startup and shutdown have their own data space, so those can be configured also. And depending on how your plant or machinery operates, if you're, say, a peaker that may start twice a day to supply power during high need times, you're going to need much more storage space for your startup shutdowns. If you have a lot of alarm events, because say it's a sludge or a slurry pump, then you'll need to assign more alarm space. So the database management has become a lot better. Now we're going to switch over to the demonstration of the actual software. Let me get back to the beginning here. So this is my simulated System 1 EVO. Just have a singular 3500 simulator feeding into this. So not everything is perfect. So be patient with some of the issues that I will run into. In System 1 Classic, we had multiple components. You had display, you had configuration, you had data acquisition, you had database management, you had licensing. All of these were separate components. Everything is kind of built into one continuous piece of software, and it's regulated by login, what you can get to. That regulation is done through tools and user management. You can have a list of people who have access to it. You can add users through this, and you can do groups. So for a corporation that wants to manage by groups instead of by individual, that way your IT group can change what section or what access you have without having to go in and do any management in the System 1 software. And then each one is assigned a role. So you have the administrator, which has all the access. You have an advanced, which might be your condition monitoring CBMs. They have more features and functions. And then you have the basic, which might be your operators, where they just really need to be able to see the data and not be able to make any long-term changes. So being based on that, we have display and we have configure. So it's very easy to swap between the two. If this was the first time I had switched to configure, this would have been locked and it would have said, do you really want to unlock it? And because I do have admin privileges, it would allow me to unlock it. The previous DAC functions are actually here in configure. So you can see what equipment is configured in the system, whether it's communicating or not. You can also get messages here like configuration out of date. So if changes had been made to the 3500 and the file had not been uploaded to System 1 yet, it would have a configuration out of date message here. The neat thing is there is a synchronize button. So once you get that configuration out of date, this synchronize button would be activated. You can click synchronize and it will go out and request the rack file from the rack, pull it back in, and give you a list of the changes. And you can say, yes, I want to change these things in System 1, or if it was something like a tag name change where they went in and put the wire tag name instead of a descriptive tag, you may not want to import that back into the software because then you'd have to go back in and change it to something descriptive so you could actually work with it. You can say yay or nay on those re-import changes. Now I'm going to switch back over to display and start walking through the features and functions here. So if you're familiar with Classic, you have the machines, which is what we used to call the hierarchy view. So I can expand out and see all the components under this 7FA gas turbine. Then I also have the devices, which is what we used to call the instrument hierarchy. And I can see, the separate cards under the 3500 if I actually had a 3701 configured, any VB lines, any hardware and OPC servers, any of those connected devices show up here. And if you click at the top, you can get a listing as to what's going on with things here. If I go back to the hierarchy, we have the list view. This gives you a list of all the machines below where you are in this hierarchy. So if I go to my gas turbines, I just have the one rack that has the 7FA1 on it. If I had this 7FA2 added to the gas turbine section, which I probably should have, it would show up also in this list. And you get a lot of good information. So here, it's letting me know that it's running. The speed is currently 3,600 RPM. It's been reviewed. There were no faults detected. The number of current alarms and the number of unacknowledged alarms, whether or not it's communicating, what the last time stamp for the data point was, and you'll see this one updates about once a second, more the update refresh rate on my screen rather than the data actually being stored. But there's a lot of great information in here, and you can sort based on, so if I want to sort by the machines that are just running, if I hit state, all the ones running would be pushed to the top or to the bottom. Sorting by speed, tag name, priority, fault conditions, any of those you can sort. Next over is my bar graphs. And I already had a bar graph pulled up with my directs and my gaps. If I want to add other variables, I can just hold Control and select them, and they are added to the screen. Very simple, very easy to add and remove data points. Next up is our overview. This gives me a list of all the machines in my hierarchy, and I can sort them alarms to the bottom, and the one with the highest number of alarms is in the very top. You can add your own tabs. So you can actually build a complete plant overview screen if you want, and add anything from a Google Maps screenshot to a engineering drawing, PDF, whatever you wish, and build out what you want to see. And you can add data points from machinery to that plot. So you can actually link on, say, a Google Maps snapshot, the location for 7FA1. You can actually drop that 7FA icon into the map, have it change colors, put the speed with it, and give yourself a great overview screen for how things are running across the plant and their locations. Now if I go over to events, I have to go back to the beginning. Sorry, I did this earlier today and I'm still at the end of everything. This gives me a list of all my alarm events, and currently I am selected on level 1s and level 2s. And now I am looking at all of the alarm events for this unit. If they are not acknowledged, they are in bold. And once I acknowledge them, I can either choose and acknowledge a single one. It does note who acknowledged it and what date and time. I can also double click on the event and be taken to a plot screen. And give it a second here. My poor little laptop trying to run server grade software. It pulls up the alarm plot screen. And depending on what type of bearing it is, will change what plots it pulls up. So a fluid film bearing will have different plots from a anti-friction bearing. And if I want to switch to wholly viewing the plot screen, all I have to do is click in the plot area and turn off split mode, and then it will switch to purely plot mode. If I switch back to split mode, it goes to the overview, but I can go back to the events. And if I click in the events list and turn full mode off, it will leave me with just the alarms. Next up is states. So states can be set up for pieces of machinery that operate differently given different conditions. So something like a hydroelectric where you're doing pump storage, or a variable pitch fan, or a pump that is pumping different materials. You can set up different states for different conditions. And these states allow you to plot similar data together and compare apples to apples. So if you're talking about something like a pump storage unit where pumping water from the river up to the storage is going to give you a completely different vibration signature than generating as that water runs back down to the river, you can create a entirely different set of alarms for pumping versus generating. And you can also do plotting based on that state. So you can compare generating to generating and pumping to pumping. Next up is the system health. This is actually imported from the 3500, 3701, Orbit 60. It's basically the internal logs for the piece of equipment. So in the 3500, there are logs for card faults and the reset button being pushed and the position of the key on the front. All these things are logged in that file, and in EVO, we bring those into the system. In Classic, we never brought them in. So this is a new feature. Used to be you had to go out to the 3500, connect with 3500 rack config to see those log files. Now you can see it here. Next up is the suppressed. System 1 EVO and System 1 Classic both had the feature that you could suppress a point by going in and right-clicking on a point. You can go to Event Management and suppress events. and I just want to suppress alarms, and I can say I just want to, I know I've got an outage in 45 days. I'll fix the problem at that time. And then if I say save, and if I ever learn to type, I will be dangerous. And I can add further notes. And then if I hit add, now I have that point listed here. And if I had not chosen to do the suppression duration, I could have it as an indefinite item. And hitting this suppressed every once in a while, checking that the points that are suppressed have not been fixed and should still be suppressed, is a great way of keeping track of what points are suppressed, which points should be unsuppressed. Next up is kind of the meat and potatoes of the System 1 EVO, the plotting. So I'm just going to kill this alarm file or alarm page. I have a lot of pages that have gotten built up over the last couple demos, and we can manage that by going to right-clicking on any of the tabs and going to manage plot session. And I can say, you know, I really don't want to see that one, and that one when I start up. And I can say apply. Oh, I'm too far down. I'm on just the bearing. So if I get back up to the machine level here, I apologize. I was in the wrong place. So now if I go in there, I can change that to related templates. The 7FA2 was built off of the same template as the 7FA1. So now if I set something up in one, I can actually apply it to any other machine that was built off the same template. So if you have 20 pumps in a pump farm and you set up plots for one and the rest of them were built off of template, then you can apply it to the other 19 without having to go through and build those plots in those other machines. So it's a very quick way of building your plot sets without having to go through each individual machine. If I want to add a new one, I can just click on the plus button here. Oops, I clicked it twice. So it added two. I'm going to delete one of them just to take a little load off my laptop. Now I can choose what I want to look at. So if I want to say look at the shaft centerline plots, add that, and say my orbit. Now I can see these. I'm going to throw a trend in here too. And I'm going to add my directs to that. So it's very easy to just drag and drop points into the system. And once I get it built out the way I want to see it, I can right click, say define as a new plot set, give it a name, and save it. So we'll just call this one demo 4. Can say, put a name in there so that if somebody has questions about why I built that plot set or what I was intending, they can come ask. The time setting is a couple of different options that you have here. The start end of mini trend range basically says that it will take whatever this time frame is currently set here, and when you open that plot set again, it will go directly to that time frame. The present time minus mini trend range. So if I create this now and I come back in 4 months and I open it, it will go back in time 4 months from the time that I opened it, because my time range is set for 4 months. Last sample minus the mini trend range is for things like portable data, where you may not have a data point but every 3 months. So it would take the last sample and go back 4 months. So if the last sample was taken 2 months ago, it would actually go back 5 months in time. And you also have the option for current values. I'm going to choose the present time minus the mini trend range, and I'm going to say apply it to related templates, so it will apply it to my 7FA number 2. Going to say enable it on the applicable machines and reset my plot space. That will basically just, any plot tabs that I may have accidentally closed, I can reopen them or add them back in. So now it should change to demo 4. And if I switch to the 7FA 2, I also have demo 4. In my shaft centerline plot, somebody pointed out that if I put in the clearances into the bearing configuration, I got the graphic representation. So in a standard shaft centerline plot, you would, on lift, you would see the shift up, and then as you build up speed and build up your oil wedge, you would see it lift and push off to the side. And if you configure that clearance correctly and you set a reference point when the machine is stopped, lift oil is turned off, and it's a horizontal machine, the shaft should be sitting at the bottom center of the bearing, and you can very quickly see if you wipe the bearing. Can be very handy in making quick assessments, and also if you set this when the machine is new, you can see bearing erosion as that point sets lower when the machine is stopped and off lift oil. Now I'm going to switch over to the demo 3 page here. Shift that to something a little more friendly to the eyes. And we have trends and spectrums. The time and date range that we have down here, I can drag that and move forward and back in time. I can also shrink that window. So if I want to look at a smaller time frame, I can also draw a box left to right to zoom in. If I hit escape, it will go backwards by each individual step that I zoomed in. Or if you draw a box right to left, it will zoom out completely. You can also set by numeric value and hours, days, weeks, months, years, or current values. Now we can get into some of the fun grouping. So we can group by point. So each individual point has its own trend page. As you can see, we now have 5 separate pages of plots. I can also group by bearing. So everything on outboard bearing 1 of the gas turbine is on 1, and everything on bearing 2, bearing 3, bearing 4, so on. I can group by machine case. So now it will be by the turbine and by the generator. So I have my turbine plots and my generator plots. Or I can put everything together on one trend. This also does stack up my spectrums. So I'm going to switch that back to by machine case so that I can demonstrate the next filtering. You can also filter by unit type or by measurement. So by measurement is going to filter by acceleration, velocity, displacement, temperature, that sort of thing. So if you had a lot of different variables coming in here, you can separate basically into apples and apples, and oranges, lemons and lemons, into different separate plots. You can also separate by unit type. So if you had some points that are coming in inches per second, some that are in mils to peak, some that are in Gs, some that are in inches per second squared, each measurement type would get its own plot window. Or you can group by none and have them all stacked together. The last one is how it pages the plots. So currently we are just sorting by plot type. So all of my trends are listed and then all of my spectrums. If I do it by point, it will do trend, spectrum, trend, spectrum. Acceleration. So this very quickly allows you to manipulate how the data is shown. And one thing that a lot of people have asked is about reporting. There is a generate a diagnostic report. You can make your notes here. There are some nice drop-down choices for what the fault condition might be, whatnot, who's doing the analysis, what points you want to include. The plots, this is for just this tab. And I can say, I just want this current page. So I basically leave off this second page over here, or I can do all pages. It does take a bit for my poor little laptop to generate that report, but it does put it into Microsoft Word, so you can then go in and edit it, add more images, more text, whatever you feel you need to do, and then it's a good starting structure for a report. Now, if I get this built out to where I'm looking at a machine problem and I go, this is a perfect example of, say, a rub. I can right click and say save as a plot record. And we'll just call it rub example. Again, you can put names, descriptions, and if there are multiple plot tabs that support the evidence, I could add them and then say save. This will add it over here to my case histories tab. And if I go to plot records, here is my perfect rub example. And if I double click on it, it will open it in a separate page. So I can then put that off on another screen, go back into plots, and pull up the same sorts of plots, or if it is built from an existing tab, so it keeps the name, I could then come in here and go to current values and compare the data of one to the other. It'll be a great help for those engineers that are coming after us to have examples of this kind of data to be able to go, well, I think that kind of looks like a rub. And if they go in and there's a case history of a rub for that machine, they can very quickly compare the two and possibly confirm or at least learn from what's in that case histories. One thing I didn't show you was once you get a plot set built and say you're on current values and you're seeing something starting to trend up, you can click on that page or that tab and tear it out. Now I can put this off on another screen and watch it on the side while I continue to progress through other equipment. And it will be locked for the time frame that it is currently set to until I change it. So if I wanted to change it, I can. But for watching a progressing issue, you might want to be on current values. All right, let's see here. The last thing I wanted to cover before we went to the questions is the software alarm configuration. This is just a great tool for setting up software alarms because it gives you that capability to do it very quickly. So if I go over to measurements, I switch to configure. Now I'm going over to measurements and I am at set points. Did I break it? Or I may just have lag and I'm clicking too quickly. Okay, here we go. So now if I click on set points and let it cycle here. Over here, you have the alarm quick configuration. And you can choose which of the points you wish to set a software alarm. I'm just going to do the directs. You have a choice of over, under, or out of band. Vibration decreasing can be as bad or worse than vibration increasing if nothing else is changing with the machine. So I'm just going to leave it at out of band. I'm going to set a level 1, level 2, and then you're going to choose a time frame. You basically want to choose a time when the machine was running perfectly. You don't want startups or shutdowns or anything in this time range. I'm going to go back an extra 2 months because I don't run this continuously, so I don't have that much data stored in the database. So to make it happier, I will just go back a little extra in time. Next, it gives you the statistical analysis functions that it's going to go through. So basically, it's going to calculate the mean or the average of the signal over that time period. And then you're going to set a percent of that mean over or under. There is this multiplier or standard deviation. Those of you that know statistics can probably comprehend that. I find that doing a multiplier of 1 gets me where I need to go. Why you use anything greater or lesser, I don't really understand the statistics of it. So more power to you if that is in your skill set. So now I'm going to set a percentage of that mean over and under for my two values. So I have a level 1 and a level 2. So my level 2 is going to be a greater percentage than my level 1. So I'm going to set this to a 20% under, 20% over. We'll do 15% under and 15% over. Then next. And it will calculate what those values should be based on that data. It tells you how many samples it picked up, what the average or mean was, and the value of that standard deviation. So now I have these values. I can click twice on the box, edit them as I see fit, and it gives you a percentage of time that point would have been in alarm with those values that were automatically chosen. If I was not happy with those values, I can go back to settings and change them again, and then do another next, and it will recalculate, and I can get to a percentage that I'm happy with. And then once I hit apply, it will populate all of these sections for the points that I had selected. So you can see now I have those alarm values set for everything in this rack. I can also go in and do manual alarms. So if I want to set this one to 0.7 and 2.4, very easily go through and make those changes. Then all I have to do is hit save, and it will apply those and start applying those alarm sets to the data as it comes in. So now if I switch back over to display, we should have some colors changing, possibly. And if you notice, we went from a light green to a dark green. If it does not have an alarm set, it's a lighter color. If it has an alarm set, it is a darker color. And anything you cursor over, it will tell you what that means. So if I go back to alarms here, I did set those kind of wide, so I did trigger them. So now I have or had 2 active alarms. I now have 1 active alarm. When the alarm is active, the circle is filled. When the alarm clears, it creates a hollow circle. And if you cursor over it, it will tell you the information about it. All right, I think we're gonna stop there so that we can take a little bit of time and answer some questions. We are approaching the top of the hour, so we will be happy to stay and answer any questions. If you have to hop off, we completely understand.
Exactly. And I'm going to go ahead and stop the recording, but first, thank you for coming.